Hi, this is Rick from Renaissance, and I'm going to show you another video here, another teaser video for our upcoming convention. What we have here is the 30 coiler, of course. Last video we showed it running off of two of these boards down here. This one we're going to show two Mosfets, so it's going to be a similar equivalent. We're running at 24 volts here, and then we're charging 24 volts. Of course, for those who don't know, this is a motor and an energizer. We don't call it a generator. Well, actually it's a motor, energizer, and generator all at the same time. So it's not supposed to be possible, but this is an Overunity free energy device. I don't hesitate to say that. So what we have here, again, is 30 motor coils and 30 generator coils inside here. The generator coils function just like a regular generator, and we're going to have a little load here on just a few of the generator coils. And this is an LED, a 100 watt blue LED, and but we have 30 generator coils inside, and of course the faster the motor spins, the more they put out. And but that's not the same thing as the energizer part of the motor. The energizer part of the motor is also putting out power, but it's a different kind of power. It's we call radiant energy. So this is we're using to this point charge batteries, but we can also power lights at the same time while charging batteries through that part of the process. So there's really three different types of outputs. There's the mechanical load on the shaft, which this is a pretty big load here. To turn this takes about 200 to 300 watts to keep in even a fairly low rotation, because this is pretty strong magnets there, and there is 20, 40, 60, 80 magnets passing by all those 60 coils, or yeah, 60 coils. So what's happening is we're running 24 volts input into the motor, and that is going through this controller here, which is what we were talking about. The Mosfets are switching, driving the circuit. There's a basic little board right here, which is just a little driver for the Mosfets. I only have two of what we're going to do is 5 or 10 Mosfets here. I'm either going to make the whole bottom 10 coiler layer into all Mosfet driven, or I'm only do half. So initially we were going to do this whole heatsink right here was going to be 15 circuit boards, and then 15 on the back. So this is only representing 2 coils being run right now. And these are the wires from the coils right here. So we only have 2 sets of wires here. And then we have the remaining 3 for the bottom layer over here, which we'll connect up later. I just want to show a teaser video just to show it running. And like I said, what we'll do is at the convention in next month, August 15th, 16th in Fort Lauderdale, we're going to be showing the video of this thing running entirely. And so for now, we're just giving you the basic idea of what we're doing. It's just a basic controller box here for the fan. We're going to turn the fan on first because we want to make sure these Mosfets stay cool. They're pretty strong devices. They're 2.5 kilowatt devices, but the pulses on this are pretty hard on them, so we're not going to push them too hard. We're going to keep them cool. So we have a switch, on and off switch, which is already on here. And then I'm going to turn the fan on, we're going to run it, and we're going to look at just a little bit of the output on these coils. Now, let me explain a few more things. First of all, as this part of the motor gets hooked up, what's going to happen is the generator coils will produce a lot more output. So this right now only represents the generator coils that we're running are not the ones connected or beside the motor coils. So as the motor coils energize and the collapse, that affects the generator coils beside them even more. So you have the magnets passing the generator coils and producing an output from that. But we also get an output from the motor coils as well. Several outputs actually. So there's 3 different types of charging that can take place for those. And ideally, when we actually pulse the right output on the generator coils, they can actually put no load on the motor itself. They can actually speed up the motor, as we've shown in our other videos. That's pretty exciting. So what we're going to do is just a constant current system in these LEDs, and that just clamps down like an alternator. So it's going to put somewhat of a load on the motor, not much. At this point, 100 watts it'll put once it gets up to a certain speed here. So what I'll do is I'll put this, connect this also up so I don't have to do it while we're running it. I'm triggering this with that's just AC on there. I'm triggering it with a Hall switch here right now. I like that because I can actually adjust the speed as I bring it closer to the magnet. There's more or less on time as I approach the center of the magnet. So what I want to be doing is putting it a little bit off top dead center. And so what happens is, as I get closer, there's more on time until the center, and then I bring it back out. So initially at startup, we want to just go easy on it. This is the difficulty of using the Mosfets without putting some kind of current limiter on it. And I don't want to put a current limiter on these because it can affect the charging. So one way to limit the current would be to actually limit the voltage. But anyway, the MOSFETs will put out whatever you give them. So at the initial startup, it's going to put out a lot more than I want to push. I don't want to either blow them out or put too much on the coils themselves. We actually can run these around 20 amps without any cooling. But sustained 20 amps each coil will probably require some cooling as all of them get used. But we're going to probably run them at 15 amps each at 24 volts. Now, of course, this system on the power side of the circuit can be run at higher voltages with being very careful, again, that you don't overheat it or too much power. There's a limit of 100 amps on these devices here, so they can easily put out a lot more. Now, as we add more to them, this will also affect each other. They won't need to draw as much because they'll be sharing the load. And of course, that will depend upon the wires that we use to run them all. So, like I said, they'll put out as much as you give them. So, what we want to do is, the other thing I want to mention is, depending on if the load is already connected on the generator coils or on the shaft, you'll have you know, more or less load on the motor, so startup will, you know, demand more. So it's better to get the motor started and running and get it up to some speed before a load is applied on this system. So we're going to be showing the same sort of system here running on the boat. So I believe we're going to try and do that, yeah, with the Mosfet circuit this time, which in one way is a bit simpler of a circuit, but it is it's difficult to work with, and it's very touchy. The benefit of the Mosfet is there's less circuitry involved. One of these Mosfets, like I said, can take the place of at least one of these boards with 8 transistors on it. But the transistor is more easily adjustable. So, but we can adjust the Mosfet with a basic speed control circuit, which we also make for our other motor, and that can vary the off time. So again, we can adjust it with this a little bit. We'll see when we start up here. And so I'm going to just turn these on and off so you can see they don't time out on us while we're running it. And I think that's it. I mentioned before it's a 500-pound motor, and it is stackable further than this if you wanted to, but it's not so easy to assemble this to get everything just right, and hopefully you didn't make a mistake because you got to take it all apart if you did. Anyway, let's get it running here, and I'm going to just, like I said, represent a no load. Well, there'll be a load on it, but I'm just going to give it a push start to get it going here so that we're not going to drive it too hard. So maybe I'll move out of the way here. Okay, well, let's turn our fan on here. So now, just a little bit start. So I want to go a little bit after top dead center, and then make sure I'm out of the way of the meters here. I think I'm out of the way here. So now what we're doing is I'm only touching it at 10 amps total between the two Mosfets. But the pulses are pretty high, going over 30 amp pulses, and that's what we have to be careful we don't go over 100 amps, because these are only rated for 100 amps continuous, but still the pulsing it can handle a little higher, but depends on the nanoseconds how long. You look at the safe operating area on the data sheet to see. So I'm only touching it here, and then we're going to go up a little bit more. Let's get this thing up to speed. You can see the LEDs turning on as the voltage climbs. So this voltage over here represents one of the other sets of wires. And I've got them hooked here, hooked up, and I don't have the other side hooked up at all. So half of this only represents half the wires. So 15 coils plus 15 generator coils. So the other half still has to be hooked up, as you can see. Okay, so now I'm going to push it harder. So we can go up to 20 amps each, so 40 amps. Of course, I don't have the battery big enough for this right now. I do have other batteries over here, but right now I'm just running a basic test. For this size, we're good, but you can see we're already at 28 volts. Now the other thing is, when we use the Mosfets and use the reed switch, we're not going to get the highest voltage spike that we do when we use the trigger coil. The trigger coil is very touchy, and so the reason why we're actually doing the Mosfets in combination with this is we have to get it up to speed to start before the trigger coil can be actually utilized in the system. Because it really, with a big system like this, it needs a real startup. That trigger coil. But the trigger coil allows you to charge really high voltage batteries, which is what this motor was for. So what we're going to do, I'm just being very careful here because we're just starting to set this up, and I want to make sure it's all good and safe. And there should be temperature meter here somewhere that I could do that with. I got it somewhere. Can't find it. Anyway, we have also temperature sensors on each Fet here that will shut them off once it gets up to 100 degrees, which is nice. So I want them on each device, that way they can handle. So we're already at charging almost 29 amps, or volts, and then we're at 28 amps. I have to get the timing right on this. It's just after top dead center, of course. And again, this is running in both propulsion mode and attraction mode, because the generator, these inner magnets here are reversed from the motor magnets. And so as the coil goes past top dead center here, it's actually attracting in the other, as the magnets pass top dead center, then they will attract in. The inner ones will attract in, the outer ones will pulse out. Here's my meter here. So we're just going to look at temperatures. See, this can handle this. Now, of course, my cover is not closed, so the air is just kind of not really hitting its target as much as it needs to. But we want to make sure the coils are. See, this is about what you want. You don't really want to go over 110 Fahrenheit. So we're at about 107. And it's pretty hot here, 75 degrees. So we're already at that temperature. So 30 amps, so 15 amps each is a nice operating area. We just got to get the ideal timing here. So you can see we're at 68 volts on the generator coils, and that's without having the Energizer part of the trigger coil influence like we have for all the rest of the Mosfets. So just want to get a couple of shots without these lights on here. Nice blue. Maybe some other shots here. Now we can put it back on. A little bit of a photo op here. Oh, I got one more light to turn off. Lots of lights on here. And actually have a lot of lights on the main light right here is 100-watt LED spotlight, and I got a couple more here. Of course, these big incandescent bulbs over here. So you can run a lot of loads here. I'm going to pick up this LED here to get speed. You got to be careful with these though. What I'm doing is it's pretty dangerous for them. And some of them respond better than others to the system. So this is really bright. It's hard to really get that from this camera because it's kind of auto focusing a bit. So, oh, yeah, don't want to do that. Just want to get a shot of another blue. Faster. Just gotta get that little spot right there, little sweet spot. So now we're running faster. So we're at 61 volts just on this one generator coil there. Once this thing really goes fast, like right now we're just touching this. This is not going very fast at all. Compared to what it will do once we get all 30 coils running. Of course, you know, you can load it down too, so then it won't go as fast. But if you, like I said, pulse the generator coils just right, then it can really go fast under load. Okay, so we're at 23 on the input battery. We're at 23.5 at 27 amps input, and then the charging battery is 29.6. And it's going to turn it off now, so you can just see some of the details. So there you have it. So I'll just turn the lights on here again. So we can watch the resting voltages for a minute here on these batteries, so you can see going on. There's no funny business here, and I'll probably take off the camera and give a close-up here in a minute. So what else do we need to show here? So what you can do with the generator coils again is you can have them in series or parallel. You know, there's 30 to work with, and they're 18 gauge wire, so approximately, well, probably over 1,000 feet on each spool. And so, like I said, you can do them here's representing series connections here, and then you could parallel them as long as you get it right, that they don't cross each other out. What else are we going to show? So, like I said, we can add speed control to this with a simple circuit. And like I said, we're going to add either 3 or 8 more Mosfets to this circuit and drive this really fast. And we'll show that video next month for those who want to come to the meeting. So like I said, on the battery side, the charging side, we want to have much bigger batteries on the output, and that's what this motor is made for, to charge a lot more battery, especially when we add this end of the circuit. So actually we can have 2 different types of charging here. We can have the Mosfet charging circuit going to one battery bank, totally separated from the other battery banks. With this system, both of them will rejuvenate batteries as well, allow you to keep your batteries longer. But there are 2 different types of charging. This is more of a positive energy output on this, and that system is more of a negative energy output. So on this system you can rotate the batteries around. With that system, what we do is we add the capacitor pulsar circuit into the output before it goes into the batteries, so that it actually gives it more of a positive charge as well, so we can rotate batteries around. But like I said, both of them will rejuvenate batteries over time. They'll go beyond desulfate, and condition the batteries. And eventually the batteries can put out more output than what they initially could. And I've got customers all over the world that have been using either these motors or the battery chargers that we sell that have experienced that for years, where they have higher gains. Anyway, you can see the voltages are stabilizing back to where they were pretty much, because we're only running a short period of time. And but the idea again is that you're charging, you're trying to at least charge 1-to-1, where your discharging is equal to your charging rate. At least with the same size batteries. You're balancing it out. Whereas of course with a regular motor, you're not charging anything, you're just producing torque. And of course we want more than that. That's why we're here. This is the whole purpose of this. So the benefits again are that we can continue to run a motor in an Overunity situation, and so we're charging a battery bank, but not only charging it. The major problem in alternative energy is battery replacement costs, and if you have to replace your batteries every couple of years, then what's the point? It's too expensive to do that. So now we can actually keep our batteries and actually improve them over time, and then so that battery longevity, battery rejuvenation benefit is important. At the same time we charge batteries, we can also run lights. I didn't show that in this particular setup, but we've shown that in other videos with the smaller circuit. At the convention you'll see one of my 10 coilers, a 4-pole, producing a lot of light on the output while charging batteries. And that has nothing to do with the generator coils, it's separate. Generator coils themselves will power other loads, like lights if we need to. So those are the benefits. Not having to have another input, keeping your batteries, and continuing to have torque, motor torque. So it is, I guess we'll say, everybody's looking for how to survive in the upcoming economic crisis that is believed to happen, going to be happening. What are we going to do? Well, there's a solution for power right here, and then for those who are concerned with the environment, this allows you to keep your batteries and not being weather related either. That's also important. Well, enough said. I will end the video here. I thank you for watching, and I hope you enjoyed it, and give me a like if you like it. Go easy on me if you don't like it. Thanks for watching.